Hi, my name's Scott Stewart. I'm a PFE out of South Africa. I've been in IT for about 18 years. I've been in SharePoint for about 11. I've been in Microsoft for about 5 years now. But otherwise, we had a session on hybrid yesterday, so that went pretty well. So I'm glad to see there's a few more people this time, considering how late everyone partied last night. I'm quite surprised to see so many here. Right, so the session's going to be maybe a little different. I'm going to take you through some of the, obviously the components of the search. And then at the end of it all, I've built something especially for the conference, which I finished a few minutes ago. Luckily, that wasn't part of it, but hey, I'm going to show it to you anyway. So yeah, I'll stick it out, and hopefully there'll be something good for you to see at the end. We're going to go through, obviously, this is not a PowerShell session, but being SharePoint 2013 search, it is kind of a PowerShell session, right? Because as you might know, you can only modify using PowerShell, so we'll get there. We'll delve into some of it. Excuse the display just now. I didn't realize this display is only 1024 by 768, so some of the screens are quite a lot larger than that. Right, so feel free to ask any questions at any point. So our first thing, one of the takeaways for you is to understand the components of enterprise search. So I'll take you through, obviously, the 6 main components. We'll talk about where they write to, what they do, how they pass the information across. We'll also go through some of the key limitations currently listed. I have taken the current performance and scalability updates off the site as of Friday last week, so I hope they haven't changed since then. But that's why I'm not going to spend too much time on the limitations, because they do get updated. So I'm not expecting you to learn them, because that's not going to help you. So we'll realize some performance considerations. We'll also understand scale-out options and capacity requirements. And then, of course, last but not least, we'll configure search via PowerShell. I'm not really going to go into, hey, here's a new service application. We're going to go a little bit more than that and rather say, right, how do we modify it? So maybe just to ask, how many people currently have search configured in the environment? Well, good. So as I expected. How many people copied the PowerShell script from the internet, pasted it in and ran it and built their search? Come on, be honest now. There must be a few. I've been to quite a few customers where you get there and they got a 10-server farm and search was running on 1 server. Oh, that's how we built it. Now, why? Because, well, I got the script from this particular website and ran it. And they don't want to fiddle with it anymore because it's working. Obviously, that's not optimal, and that's why we're here. So a quick agenda. We'll go search overview, some performance requirements. It looks like I have to stay on this side because this thing's got a low range. We'll go through scalability, deployment in PowerShell. All right, so let's jump straight in. In the top right, you'll see we talk about the color coding. That's just the key for it. Public API, content extensibility points you'll see in blue, and then unit of scale, the boundaries you'll see in green, and then obviously the databases themselves you'll see in brown, a dark gray or a black. So what's up first? The crawl. Now the reason this one and I highlight it particularly is it's kind of the odd component of the lot. And you'll see as we go through why I call it the odd component, and I will spend a little bit more time on it. Next up is our content processing. From there, we're moving to the index. And as we know, the index is one of the heaviest components. And in fact, if you modify topology, the index will be the one that takes really long to reconfigure. We have query processing. And after that, analytics processing. And last but not least, of course, the search administration. And you'll be happy to know that the search administration actually has some redundancy now. It isn't a single point of failure. Just remember, you can only have one of them active at any point in time. If we go to the databases, you'll see we have the crawl database. Now, what happens with the crawl will physically go out and actually collect the documents or pages that you've specified in your content sources. From there, what it's going to do is it's actually going to write to local disk under the service account that's running the service, which is the MS Search service we'll see a little bit further on. So it writes into its local temp location, and then Anna brings down the metadata, the crawled properties, and that will then get passed into content processing. So we get a lot of questions, well, how much space do you need in the temp location? Well, it does depend, unfortunately. It depends on how fast it's crawling. It depends on how many threads it's opening at any point in time, and how much content it's going to bring down. So it doesn't help if you have a 50 gig C drive and you've used it all up to copy all your install files on, and you're leaving 2 gigs behind and wonder why the crawl's taking forever to run. It is going to have an impact on it. Next up is the link database. That's for the content processing. Then we have analytics reporting and the search admin database. We will go into this in a little bit more detail, so don't worry about it. From here, we can obviously see the search admin writes to the search admin database. On the left-hand side, you're going to see what type of content we're going to be able to crawl. Just some basics, obviously HTTP, file shares, SharePoint locations, user profiles, out-of-the-box Lotus Notes, Documentum. You'll notice Exchange is there as well. So I don't know how many people know Exchange 2013 uses SharePoint search, actually, for its search. You've also got custom folders or even BCS. Right, so crawl writes to the crawl database, pretty obvious. But we'll go through the limits on this, so I'm not going to spend too long on this. I just wanted you to see the process that it goes through for the search itself to actually run. This scrolls out to quite a lot, and you'll see as it goes, crawl goes to content processing, content process goes to index. And unlike 2010, you will see that we obviously have analytics processing. So I don't know how many people laid web analytics in 2010. And you've noticed that when you went in 2013, it no longer exists. That's because it's obviously been moved into the search. So you can't have analytics without the search being configured. The reason this was done was for scalability. And we didn't see the point of actually going into and analyzing the data twice, one in analytics and one in the search. So it's done as part of the same process now. From here, you'll notice that analytics processing also writes to the search index. So that's another thing that's a little different, and why it does that is because as the data is getting analyzed, and as the number of clicks that people are taking, we are going to obviously influence the index component. Otherwise, your relevancy wouldn't be up to date. So as you're busy working and actually going through the search, and the more you're searching and what you're searching for is starting to slowly but surely feed from the analytics component and into the index. And we see this when we look at the queries in the web front end. If someone makes a query from a user interface, and notice it's not just SharePoint, it's apps as well, it's devices, and it's even non-SharePoint user experience. From there, it's going to pull into the from the web front end to the query processing. At the same time, it's going to write to the analytics processing component. The query processing and then going to go to the index to fetch it. So it's not like Fast used to do where it made a copy of the index for the query component to use. It isn't doing that. It's physically going to the index component, making a query against it, and bringing back the results to query processing, which will then take it back to the web front end, and then obviously to the end user. Now it's important to understand that obviously these, if in the past you lost your index and your query component was still available, you could query and people could search and they would get results. Unfortunately now if your index component goes down, you will not get results because there's nowhere to get them from. And that's why you'll see later we'll talk about replicas and we'll talk about partitions, and we start going into a few new terminology that some of you may not have heard of yet. Right, some additional sort of extensibility areas is the content enrichment web service. That's an extensibility point. So you can customize against that. You've also got custom connectors that you could build. Don't worry, the slides will be available to you, so if you want to see a little bit more on it, I have got a whole write-up in the notes as well for it, so you can go through that. Now let's look at the service and processes very quickly. It has two main system services, one of them being the SharePoint host controller and the other one being the SharePoint search server. And on that, on your machine, you're going to see that physically in the services, you will see a SharePoint Search Host Controller service and a SharePoint Service Search 15. Now, why are you going to see the two of them? Is because the Search Host Controller service, first of all, if we have a single server environment, has 5 node runners. Now, I don't know if you saw on the last diagram, the search actually consists of 6 components. So why on earth would we have 5? And the reason we have 5 is because you'll notice in this diagram on the left here and then on the right, there's something called the node runner. Now, you can tell me what's missing from this out of the 6 components. Anybody? Yeah, the crawl is missing. And the reason the crawl is missing is because it doesn't run under the node runner. It runs under the MS Search executable. And for that reason as well, you cannot have more than one crawl component running on a server. If you try and activate it in a topology, it will tell you that it already has a crawl component in the topology. It doesn't mean you can't have more than one crawl component, you just can't have one crawl component on the same machine. And if you look on again in your services, what you'll see is there's the node runners, and here's your search crawler running under MS Search executable. You're going to see a couple of other things as we go into the crawl. So let's jump into the crawl very quickly. And what you're going to see here is you've got MS Search executable is where the crawl is running, and you've got node runner for the other 5 components that actually run content processing, the query component, the English component, and all those run under something called the node runner. So they're essentially isolated components. What that means is the service for MS Search is only for the crawler and gatherer process. Now, if you looked at previous versions of SharePoint, you would have seen MS Search was there as well. The same name has been carried through, and it still exists for the crawl. If it's going to go with me. Its startup is manual. Please don't sit there and start it yourself. I've seen people do that. It will start when a crawl starts. And if you have a look further, what you're going to see is you're going to see a couple of MSS daemon executables running. Now, these are effectively there because they're depending on how many protocols you have in your content source as to how many MSS daemon processes you're going to see running. What's great about these is if they happen to crash, they have no impact on the crawl and they'll simply restart themselves, because they will not crash the MS Search executable. All right, they'll just start up again, and it'll build a whole new MSS daemon executable again, and it'll do it again. So if we look at the crawling architecture, the first thing we need to know is crawl components can have multiple crawl databases. And you'll see in the diagram now what happens. What you'll also see is that each content database is crawled by a single crawl database. So if I've got more than one content database and I've got more than one crawl database, they'll each go to a different one. You'll see that in the diagram now as it goes forward. The current supportable limit is 20 million items per crawl database, which is why you can have multiple databases. I was at another customer where they said, oh, we don't have a lot of items. And I looked and they had 10 million documents. I said, and you're wondering why it's taking 60 hours for your Unix to run, build a new Unix on a single server? So yeah, you've got to take these things into consideration. And how that works is, in this case, we have 2 crawl components. We also have 2 crawl databases. And in our case, we have a portal and an intranet site that we're connecting to. If I'm hitting portal, the 2 crawl components can hit portal, but guess what? They're going to write to a single crawl database. And if I look on the other side, again, it's hitting intranet, it's going to write to the other crawl database. So a crawl component is not isolated to one crawl database. And this is what we call content database affinity. All right, so don't expect it to load the content onto different databases. It's not going to do that. If we look at the crawling process, we've got 3 crawl schedules. Now, we all know the first 2. I mean, hands up who hasn't worked on search ever. Any 2010 people in the room? Must be a lot of SharePoint 2010 people in the room that have worked on search. All right. So that part of the schedule hasn't really changed. We have a full. The only problem in the past was that when you made certain changes, it went full regardless if you wanted incremental or not. And one of the biggest things was that is from the security side. You'll be happy to know that's changed in 2013. If you make security changes, it does not initiate a full crawl. Whereas in 2010, if you added a user to a particular library or list, you would initiate a full crawl in order to change the ACLs. The next 2 up, we have incremental crawls. An incremental crawl, I mean, that's fairly self-explanatory. It's going to go through and look at the change content, and it's going to then obviously initiate a crawl just on the changes. And you'll see just now why there's such a big difference between incremental and continuous. Continuous crawl is actually a predefined incremental crawls. The only difference with it is that it isn't restricted by the incremental crawl rules. And you'll see it in the next diagrams as we go. So let's look at crawling schedules for a moment. If we do a full crawl and then we do an incremental crawl, what's going to happen? If there are deep changes, and we expected the crawl to take a certain amount of time before the next incremental crawl, but the deep changes have occurred in the content, they are going to push past their boundaries and push all of the incremental crawls out. An incremental crawl cannot overlap. Sorry, yes? Sure, okay. Yeah, you could have done a whole move of documents from another. I mean, I've seen a customer do it where they did a mass export of 50,000 documents from one library to a complete another library, as one example. They decided to change all the content types that they were working with and moved all the documents over into different content types. So, I mean, to define a deep change is a little bit broad, but ACLs isn't one of them anymore, thank goodness. So it's more around something that has more changes. Oh, how's a good way to put it? I'll come back to it. How's that, if you don't mind? I'll come back to it for you. Right, so if you have a look at this incremental crawl, if there's an overlap of it, it's not going to overlap. It's simply going to push the crawl schedule out. You cannot have multiple incremental crawls running at the same time for that particular content source. So what does this do? This leads to latency in the changes of the content. Because I uploaded new content, and now I'm waiting an extra 30 hours because the incremental crawl is taking longer. So what's been introduced to potentially solve this is something called the continuous crawl. Now, even though the continuous crawl is effectively multiple incremental crawls, content changes do not affect each other in the different crawls. Meaning, if I happen to be in the content crawl number 1 and I uploaded a document, let's say an hour ago or 15 minutes ago, and somebody else uploaded another one that had a smaller content crawl, their content will actually be visible before mine because it's not impacted by each other. It's launching multiple incremental crawls. These are done by default every 15 minutes. There are some limitations, however. Only SharePoint sites. And I say every 15 minutes by default. It can be dropped down to every minute. Just bear in mind, if you're going to do this, understand the processing power you need behind it. One content crawl process per service application. Now, what does that mean for us? You cannot set up different schedules or change the timings for continuous crawl for different content sources, because a continuous crawl, as it says, it's per service application. You also are unable to pause a content crawl. And if you do happen to stop it, it stops it for all content sources. Right, so there are a couple of limitations around it. They do coexist. All right, that's an obvious one. You can see that clearly by the diagram here. This is just content change spikes. There's low spikes, and they're really quite independent of each other. So let's look at content processing. Right, I know crawl I spent a bit of time on. I know there's still some more questions, and I'll come back to that one. But the reason I like to spend more time on the crawls is because there's always questions about what happens to my content and how does it move. What we need to understand is that if I've pulled down my content, it's dropped into a temp location on the local disk, which would normally be C users, SB search service account, app data, local temp. It's going to put it in there, and then it's going to pass it across to the content processing component, which is the one we're coming up to next. Now, why that's important is obviously because it's right into local disk. And you'll see later as we talk about the impact on disk and why performance is required and why we have more disk, need more memory, and all these things we'll come to further on. Now, the big thing with the content processing component, and it isn't listed here, is that if I've got a crawled property that has been defined, so essentially the crawler's brought it down, brought the document down, brought the property down, and it's passed it on to content processing. When content processing is passing it across to the index component, if there is no managed property for that crawled property will not exist in the index. So if you haven't defined a particular property and gone into the configuration and said, hey, I need to add a managed property, it won't exist in the index. All right. You'll see that if you go into the search. I mean, that's not really part of performance and scalability, but just something for you keep in the back of your mind. So, processes crawled items, and it feeds to the indexing component. What you're going to see is this is where it does the document parsing. You can also see this is where we apply the R filters. If you've got a custom, this is where it's going to do the work. The other thing it's going to do is it transforms the items, and they become index artifacts. It also does, and this is new for 2013, it does linguistics processing at this point. This is not the only time linguistics processing is done. We do have some linguistics processing in the query component as well. Okay, that's something new though. And it writes the link information and the URLs to the link database. I mean, that's not really complicated. There's a link database, it's writing links. I mean, that's fairly easy to remember. It generates phonetic name variations for people as well. Right, so content processing is quite a fair load of work. What about the index? Right, so now we get into the fun stuff. What is an index partition? So let's take for a moment and imagine that this room is an index. We've got an index sitting here, and we want to split up that index so that it's not one massive component. So we're going to say, right, this part of the room, you're going to be part of index partition 1, and you're going to be part of index partition 2. I lose index partition 2, will I find any content sitting on that side of the room? No, because it doesn't exist in index partition 1. We've effectively split the room up into two parts. So this is one set of content that we're throwing in the index, but we're putting half of it in index partition 1, and the other half in index partition 2, which is why you'll see that we want you to have replicas. So should you lose one, the replica would then take it over, and you'll see what a replica looks like shortly. So each partition is served by one or more index components, otherwise known as replicas. And there's a little diagram, it's not just text, don't worry, we will go into it. Not all replicas, unfortunately, are obviously equal. It does depend on the original index component that they're a replica of. But all replicas are there for fault tolerance and obviously increased query throughput. Because remember, indexes are queried by the query component. So this is probably about the best description of what a partition and a replica is. An index scaling horizontally is our partitions, and an index scaling vertically are our replicas. So to bring up a nice diagram about what it looks like, and this is probably a fairly complicated deployment, what you're going to see here is that we have partition 1 on app 1, and we have a primary replica sitting on app 1, and the secondary replica sitting on app 2 in this case. But it doesn't mean that another partition can't have another replica on the same box. So you're not forced to having to go and buy 10 or 14 servers just because you have multiple partitions and multiple replicas. Obviously, if you have a lot of content and you're wanting to split up a lot of partitions, then you're going to end up with a scenario where we're already on 6 boxes in this case. All right, so a partition is a mechanism for you to split up the amount of content in the index, and a replica is for you to provide redundancy for that index. Now, whether it's index 1 partition, or whether it's, so you've got 1 index partition and 1 replica, or whether you've got 5 index partitions and another 5 replicas on top of that. You'll see there are some limitations though. You can only have 60 search components per search service application. Right, we do go into a bit of the performance limitations, and I'll go through those slides quickly because it's not something we're going to remember. Right, so what about query processing? Now, query processing, as I said to you, when someone makes a call for a search, it's going to hit the query processing component, which is going to go to the index component, make a query to it, come back with the results, and pass the query back to the web front-end server to hand off to the end user. It's not like it was previously, where you made a query call to the query, and it came back with results. It didn't query the index before. So if we go into a little bit more detail, you'll see there's our search service application proxy. Actually makes a call to the query and site testing service, which then makes a call to the query processing component, which then in turn makes a call, and in this case there's 2 partitions, so therefore I'm making a call to 2 different locations because they're different partitions. Partition 0, partition 1. If I want to find all the content, I've got to go to both. If I was going to 1 big index, there are some performance limitations obviously, but how many items you can have in 1 index. And there are obviously some optimization techniques to having more than 1 index partition. Okay, the analytics processing feeds into the index to affect, and I actually do have a slide on it further on, if you don't mind hanging on for that. Cool. All right, so if we're going to have a look, first of all, as I said to you earlier, linguistics processing is done on the content processing side, but it's also done on the query side. We also have the fact that it receives queries and analyzes and processes them, and then it also processes the query submitted to the index component. It looks at which query rules, which index am I going to go into, and then it does pre and post processing of the query, because obviously I've gone and made a query to the index component, then I've got to move along and I've got to finalize what I want to present to the end user and then hand it off. It's not a simple thing, how am I going to go fetch it from the index and I'm done. All right. It returns a result set back, and then it obviously processes, like I said, and sends it back to the end user. Right, so analytics components. I hope this gets to your question now. If we have a look at the analytics component, what you're going to see is there's an interaction between content processing and analytics. There's also interaction to the linked DB and the analytics database, and it pulls information from the event store. So first of all, what does it do? It analyzes the crawled items. Step 1. It also looks at how users interact with the search. Now, how does it know how users interact with the search? Because when someone searched at the query component, what did we see? That arrow go down and say, hey, I'm writing to the analytics component. So that the next time that the index is refreshed, that information is now pulled into the index, and the results that are coming back with the query gets made will be influenced. Because what happens if a user clicked on document number 3 every time he searched for the word SharePoint? Does it help that it stays at document number 3 on the list? something's got to move it up and improve the relevance of it. How else are we going to know what people are searching for if we don't write them away? So this is where it writes to the analytics component. It also analyzes usage events, like views from the event store. If a user performs an action, for example, they view a page, this goes into the usage files. The web frontiers regularly push event stores, so they're going to push events that they've got down to the analytics processing. So there's a lot more interaction going to the analytics processing component. Then previously we had web analytics running and you'd get a timeout because the information was too big and it was out of date because it crashed when it was doing an update. I don't know if anybody had that experience. We hit the bottleneck of the web analytics before. Anybody? Nobody? Wow, we had a big environment then. Right. Does this touch on your question? And then it sends results to content processing component to then also be included into the search index. So what you're seeing is the analytics processing component is sitting at the bottom of all of this and getting feeds from multiple locations, and at the end of the day influences content processing, influences the indexing component, and also is getting feed from the query processing component. And all of this happening as individual entities. That's why I showed you that diagram right in the beginning, and I knew I'd come back to it, because each of those components, except for the crawl, runs in something called the node runner. And the node runner is essentially a wrapper that pulls that component up and lets it run on its own. So all of these things run on their own, but talk to each other. And you can even write code to add events, to the analytics component. Right, what about the admin component? There's a couple of changes in this. First one is everything up and running? That's a pretty obvious one. It uses the search administration database, again, fairly obvious. It can have multiple. Now this is obviously a change. Previously we couldn't have multiple. We still had a single point of failure because we only had one administration component. Now you can have, if I'm not mistaken, up to 6. We'll see it later in the slide, or I've got it in the notes there. But only one will be active at any point in time. So if it fails, another one will then obviously take over. So what does this store for us? The topology, you'll notice it's got the crawl rules in it. It's got query rules. It's got managed property mappings, the content sources we're going to go to. It handles the crawl schedules. Notice the crawl database doesn't have the crawl schedule in it. Okay, it's sitting in your administration component. It stores analytic settings, and a big one, we no longer store the ACLs anymore in the administration database. Previously that was stored there, and any major change would kick off a full crawl. That's no longer the case. Right, so let's have a quick look at, hopefully the screen's not too small for my server. And of course, before I started the session, I was making changes to my environment, and I see they are still applying, but that's fine. We do these things. Come on, over you go. Right, so I'm sure most of you have seen this page. Apologies for the resolution. What you're going to see on here, and something that I'm more interested in, is in my environment, I'm running this locally. I currently have my topology of 3 servers. I've got 2 app servers and 1 single web front-end server. What you're going to see here is that one of my crawlers hasn't come online. That's because I was deciding I'm going to play around with modifying topology, and I'll show you that just now. But the nice thing that you're going to see with the new UI is that obviously you can see what's available, what's online, how many partitions you have, and which servers are running which components. In my case, I decided to run 3 query processing components. A little bit silly, but that's what I've done for here. If you have a case where you're seeing this that I'm getting here, this crawler is not online. If it's red, it means it's being removed. And now, as you're making topology changes, you'll actually see the topology changes occur on the screen. Please be patient. It is not a 1-minute change. I did this change before I started the session, and the crawler is still not online yet. And if it doesn't come online, I'm going to remove it and move it to another box. But I'll use something that I've done to do that. So that's just a very quick look at what the search looks like, and I'll show you this just now as I've made changes to it. All right, let's look at scalability very quickly then. So what scalability directions can we take? We have some independent scaling. Obviously the content volume, how many items did you have? The other thing is the query load. People look and say, well, I don't know how long people are going to, how many queries per second we're going to get. Well, the only way you're going to know that is if you're looking at the logs. If we're monitoring what people are searching for and we're monitoring how often they're searching, it will actually show us the queries per second that are being done. It also looks at the crawl load, and people say, how long am I going to take for my crawl to go through? Well, how much content have you got? What kind of documents have you got? In the past, if you were using 2010 and you were using the Adobe PDF R filter, good luck with getting it to run fast, because it's a single threaded R filter. Luckily in 2013, the PDF R filter is built in. So there's a massive improvement on that. I have a customer now where it takes 66 hours to index. And we told them you need to replace the PDF R filter because you're processing one item at a time. It's a single threaded process. I'm not going to say what we told them to go to because obviously that's, I mean, I work for Microsoft. I don't want to endorse something. I'm very careful what I say. And then of course we've got multiple workloads. We've got SharePoint collaboration, SharePoint websites, Exchange, and even Office 365. And if you saw, we did a session yesterday with Neil and Manis at the back there on hybrid troubleshooting. And funny enough, we ended up showing a search hybrid environment, how to break it, how to troubleshoot, how to fix it. So if you didn't see any of the hybrid sessions, I suggest you go and look at them because it is showing you how to actually have search in a hybrid environment. We obviously don't have time to go through that in here. Right, a couple of scalable components. The query processing component, indexing component, you'll notice that they're all here because they're all scalable. That's the point. So you could scale the query processing component through the query flows. There used to be old terminology for that, but I'm not going to go into that. There's index component, which is indexing and query matching. You've got the crawl component, there's connectors, you can do BCS. That's why I showed you that initial diagram, so you can kind of get the idea that it doesn't really matter where we're getting the data from, it doesn't matter really where we're getting the queries or the call from, and at the end of the day, the components are staying the same in the middle. Now, the biggest thing is that people ask me, do we scale up or do we scale out? So you need to understand what are the drivers behind that. What makes you scale up? If you're scaling up, it means we're adding more RAM perhaps. If we're scaling up, it means we're adding more processors. But does it help to scale up and go from 12 processors or 12 cores to 16 cores when I know that search cannot use more than 12 cores? I've had people put 128 cores down. I'm like, well, what's the purpose? It's not going to solve the problem for you because your problem you have at the moment is processing power. How do we know that? Because you've gone and monitored which processors are being the highest impact. And it is limited to 12 cores at the moment. We've got there's a slide on here showing you the limitations, so don't worry. Right, so what impacts the crawl? First of all, the CPU load, the documents per second, link discovery, and crawl management. That's CPU load. Network load. We're downloading items, and we're passing items to the content processing component. Why? Because obviously it's passing to a different server. So there's a network load involved. Disk load. As I said to you, they're temporarily stored in the temp folder, and it's not your temp folder. It's the temp folder of the search service account. where it's going to store it. And you can only have one crawl component per server. Notice, not per farm, per server. You're allowed 500 start addresses or content sources. And you are limited to 15 characters for the host name. Please don't give your server names these massive long names. Stick to the net bias names. Stick to the, I've had people who create search service, SVC _ search service account for SharePoint 2013, and they wonder why it doesn't like it. All right, stick to net bias names. It's still a limitation. And you're allowed 15 crawl databases per service application. Right, these numbers do change, so I've thrown out the current numbers. The links are in the document right at the end. Right, so if we look at content processing, again, CPU load, we're looking at documents per second, document size, their complexity, and feature extractions. And this nice little one is a new one that I actually found. It's a number of cores times 3 will give you the number of feeding sessions for the content processing component. So the content processing component will load multiple parallel sessions to feed the content. But it's the number of cores multiplied by 3 that will give you that number. And in this one in particular, this one is the one where we are limited to 12 cores. So even if I have 16 cores, I can't go past 36 feeds at a time. What will happen, you'll see on those 4 extra cores that you've now added, they'll be sitting idle. All right, so it's important to note that what's the point of throwing 16 at it if I'm only going to use 12? All right, other things like network load. Obviously, how many documents per second, the document size. And you'll notice in this case, it's recommended 1. Not forced to 1, recommended to 1 for obvious reasons because it's using up cores. Indexing. Now, this is probably the big one. Biggest thing is CPU load. It's about queries per second, the item count. And the guidelines here is 1 million items can do 5 queries per second per CPU core. 5 million items can do 2 queries per second per CPU core. And 10 million items is 1 query per second per CPU core. Now, obviously, these are estimations based on, depending on the cores, depending what's running. It could have this bottleneck. There's a whole lot of other factors around that. What you'll also see is that the disk size is about 500 gigs for 10 million items in an index component. And we are limited to 60 per service application and 4 index components per server. So I can have 60 search components altogether, but I'm limited to 4 index components for 1 server. All right, whereas if you saw on the content processing, we recommend 1 content processing per server. And you saw on the crawler, you can only have 1. I tried to do 2. And it comes back very nicely and says, sorry, 1 crawl component already exists, apology, fail. All right, index partitions and replicas. I need to speed things up a little bit. You're allowed 25 partitions per service application. If you increase the partitions, and this is a very positive point, you reduce the amount of RAM you use, and you reduce the amount of disk by increasing the number of partitions you have. So if you have 1 index partition, and you split that up into 6 index partitions all of a sudden, you will have a reduced amount of RAM and a reduced amount of disk. You're allowed 3 replicas per partition. So if you don't know what replicas are, I mean, you saw in that diagram, a replica is basically a copy of it running, which will act as a failover component. If you run in SQL, you'll notice SQL always on has replicas as well. So the terminology is similar across the product set. Increased number of replicas gives improved query performance and fault tolerance. Because I'm going to one and it's too busy, I'll move on to another replica and I'll improve the performance. I mean, it's pretty straightforward. It's going to do that. So let's look at index list IOPS, and I'm not going to ask you to remember these because it's quite a bit of information. A typical crawl load is 10 to 60 IOPS at 30 to 512 kilobyte writes. The query load at 10 million items during high crawl rate is 30 reads per query. If you're not crawling, it's 3 times reads per query because it's cached. If you're busy with an index merge, then it's 150 concurrent, 150 megabytes per second read and 150 megabytes per second write. Because remember, when indexes are changing, they have to merge at some point. But the nice thing is, all the loads can occur concurrently. There is no waiting for one to finish before the next one starts. Okay, I'm not asking you to remember this because this has changed recently. I had to update this on Friday. Right, query processing component. CPU load, based on the queries per second. How many transformations are we doing? And the guidelines here are 4 queries per second per CPU core. I'm mentioning all these things about CPU and core because a lot of people are asking these questions about, well, how many do I need? What happens if I give it 128? Well, it's not going to help you. I honestly had someone who put down 128 cores and 2 terabytes of RAM on a SharePoint server, and I was asking them what they were trying to build, but rather give me 10 virtuals out of that. All right, network load, it's based on the number of index partitions, the size of the queries and the result, and an example of this is 20 index partitions at 20 queries per second equals 200 divided by 100 megabits per second in and outbound. So 200 megabits in and 100 megabits out. Okay, don't try and remember this because I don't remember this. I'd rather take my environment, work it out, calculate it per individual per environment. So when someone asks me, how do you do this? I give the consulting answer first. Well, it depends. And we all know that it depends because it does. It's SharePoint. It does depend on how your usage of it is. And a query processing component, only 1 per server. You will start seeing that we recommend doing 1 of certain things per server. It's only the indexing one that you can go up to 4 on it. All right, analytics processing. CPU load is the number of items and how much site activity. Obviously, how much does it have to go through, how many sites does it have to go through, will impact the CPU load. Disk load. Are we using local? Or we are using local disk for temporary storage again, and then the bulk load is obviously the primary concern is because a bulk load is you've got low isolation. So a network load, it's the same as the CPU load, plus it increases when you distribute analytics processing components across multiple machines. Well, that's pretty obvious. Because if you go one analytics processing to another one, you're going to have that traffic going across the network. So don't think by just adding more components, I'm reducing certain items. Network load will increase because of more components. 1 per server and only 6 per service application. And in this case, you can have 4 per service application, 4 databases. All right, these limitations are there. You're starting to get the fact that when we're starting to hit 100 million items, you seriously got to start thinking how you split your content up and how you split your databases up. We have questions about splitting the linked database, but that's another discussion that we aren't going to have here. All right, the admin component, it's low CPU to network load. Load increases obviously with more components. That's pretty straightforward. Right, so let's summarize some of the limits. 4 linked databases per service application, 500 content sources per service application, 64 components per service application. So even though we told you you could have 60 index components, you can't have 60 index components and then have another 5 crawl components because then you exceed the limit for the service application. So this is a hard limit of 64 components in a service application. You're allowed 20 service applications in a farm. Right, so let's look at scale out and optimization. What can we put together on the same servers? Content processing and analytics can be put on the same server. Search administration and crawl can be put on the same server. And index and query processing can be put on the same server. It does depend on the resource consumption. And it also the component share, obviously we split bulk processing for query traffic, avoid sharing critical resources. It doesn't help if you've given them, we know that, for example, indexing uses high CPU load, and so does content processing, and yet we've tried to put them in the same box and we've given it 4 cores. Because then you're going to sit and wait, and if you want to wait the 60 or 90 hours for it to do its work, then you're going to wait your 60 or 90 hours for it to do its work. Right, so let's look at a quick cheat sheet. Most of you have probably seen this online. What you're going to find is search administration. This is just a quick summary. I've been through most of this. And you'll see obviously the asterisks that we have. Query processing is network and memory dependent. Indexing, well, it's dependent on everything. You might notice that. The only one that's a little bit light on is network. So the index component is still the heaviest component of all. And then analytics processing is very heavy on network. And if we look at memory for your content processing component. If we look at the crawler, notice the disk. That's something people forget. Oh, but it's writing to the database. No, it's not. It's writing to the temp location on the file system. And if we want to scale for size, we're starting to really get into some detail. The general guidance is 1 index partition per 10 million items, 2 components with 1 partition, and if you get 10 to 40 million, there's 8 components and 4 partitions. 100 million items, you're going to have 20 components and 10 partitions. All right, this is a quick guide for you. It is in the slide deck that you get. So I'm not going to hit every single item, but this is also another quick cheat sheet for scaling. All right, I'm not saying this is the be-all and end-all, but this is a good guidance from the product group. And again, some more detail on it. If you want to improve your full crawl time and result freshness, add more crawl databases. Add more crawl components, content processing components, because again, it's about how fresh are my results, how fast are my queries. I mean, that's why we're optimizing the search, isn't it? First of all, we optimize it by having continuous crawl. But can we have continuous crawl when we don't have the hardware to support the continuous crawl process? Okay, so these are just a couple of cheat sheets in the slides that you can go through. Right, and if we look at database sizing and load, this is quite a good one for you. If you look at it, you'll see that 1 database for 20 million items. We need 10 IOPS per document processing. You need 1 database for 60 million items for the link. Be careful of the link DB. If you split the DB, don't expect it to load balance it continuously, because it doesn't do that. So if you're going to split the link DB, then I suggest you ping one of us about it. I don't know if anybody's had 2 link DBs yet. Anybody? Okay, if you do split it, it's a point-in-time split. It is not, I'm going to balance after you've split me. Okay, just keep that in the back of your minds. Right, so let's jump into the stuff that I really wanted to jump into with you, and let's go through some of the PowerShell. Considering that I know it's coming, there's only a few minutes left. If we look at it very quickly, you will see these are the basic commands. This is not all of them. The key commands here that you're going to see is that, obviously analytics, each component, and you'll see the 6 components are there, have their own commands that they run. One of the ones that you're going to see is you'll see that my variable there is called $clone. I haven't showed you the clone command in here. And you'll notice the very last, but certainly not least command on the bottom here is to set the new topology. I'll show you some quick PowerShell, and then I'll take you to the thing that I said I would build, and I finished it 99%, so I can show it to you. It's going to be very interesting for me to read like this, but let's see if we can clean up some stuff. Here we go. Right, obviously the first thing we've got at the top is adding the snap-in. I'm sure everyone's seen that. You add the snap-in, it takes its time, and it adds it. The next thing you're going to see in this case is that I'm physically checking to see the search service instances online. Why? Because what happens if I have two servers like in my farm, and I only recently, in fact on Monday, I added a new server to my farm. You can't just go and throw search components onto it because the search service instance hasn't been started yet. So all this does is it goes down and says, go and get me the instance, check if it's online. If it's not online, go and start it. And while we're waiting, let's stay there and check and keep checking until it comes online. Because if you don't do that and you start setting and sending components to it, guess what? That topology will not activate. I'll post this code on my blog so you can have a look at it, but I'll post something that's even better afterwards on the blog. If we scroll down now, you'll see in my case, I'm doing a two-search server deployment. I'm simply checking both instances, and after this, I'm cloning the topology. Now, the really interesting thing you're going to see with 2013 is even if you go to the UI and you say, create new search service application, your topology is empty. So you have to go to the topology and say, clone my topology, even though it's empty, then go and add components to the topology, and then go and set it. And in fact, if I recall right, we're having a discussion about it. There's two commands to activate the topology. One is .activate, and one is to set. The weird thing is the set activates the new topology and deactivates the old. But you have to use the .activate command if it's a brand new topology you've just created because your topology didn't exist before. Otherwise, it fails. Okay. What else you'll see over here, and I said it was partly a PowerShell session. I mean, if you don't know, can't handle PowerShell, then unfortunately then you can't modify your search topology. We need to get that straight out and out in the open. There's no UI for it. Well, I'll show you just now. Then, of course, we've got to be able to remove, and I'll show you that in a bit more detail, but you can remove. And the reason why you have to remove is because if you clone a topology, and you've got an index component called index component 1, or that's a bad example, query component 1, and you say, I'm going to add another query component on the same box, it doesn't overwrite query component 1. It says, oh, I'm in here still, and now you've added me, I'm going to add a query component 2. So when you activate the topology, you're going to have a query component and a 1 and 2, even though you didn't want that. So if you're modifying topology and you want to remove something, you have to take it out. It doesn't overwrite it, which is why there's a remove topology command. And then the other thing you've got to do is you've got to set where you want the topology created. In my case here, here's my analytics, but which search service instance that I want to start it on? You'll notice I've got a 1 and a 2. On this one, I'm showing all my 2s. So it depends on which which search service instance, on which server you want to start the topology on. Now, a couple of gotchas. You have to have at least one of every single component in your topology, otherwise it will not start. The other thing that you've got to consider is if you have an index component and you decide to modify your topology, you cannot remove an index component if there isn't a replica for it. So I can't say I'm running on server 1 index component and I want to now move it to server 2. So I'm simply going to remove it and add it on the other one. You can't do that. You have to add the second index component. Then you have to modify the topology again and remove the first one. The search will not allow you to create a new index component if you already had one before. And if you do happen to do this and get away with it, you will need to recreate your search service application from scratch. Okay. So if we scroll down, you'll see this is just a very basic script. And at the end, I'm setting my topology to the new cloned one. The other really cool thing about it is that if you happen to set to the new topology, don't forget to clean out your old one. Because just because you deactivated it doesn't mean you deleted it. All right, again on my blog, I've put a little delete command there that goes through and just spins through or any finding inactive topologies and cleans them out for you. It's not going to hurt you to leave them, but of course it's a bit messy if you do. All right, so to get to the surprise that I wanted to do, something that I've been trying, that I decided as one does, let's build something in the week that you're presenting. So that's what I did. Where's my machine? Now, I apologize if it doesn't fit on the screen very well. I'm trying to see where my mouse is. You'll see my topology here. So I'm going to minimize this very quickly. Oh, you're kidding me. Is mine still running? All right, what I've done, I'm just going to break it because I don't want to keep waiting. I'm impatient. What I decided to do is write a little bit of PowerShell. And you can't judge my PowerShell because, well, you just can't, okay? I wrote it in a very short space of time. Oh, for goodness sake, come on. I'm going to do what I really shouldn't do, but I'm going to do that anyway. Man, this screen is hard to work with. Goodness gracious. And I'm going to open my PowerShell ISE quickly, as administrator, obviously. And we're going to go and open my new modify search topology. I'm going to post this up on the blog, but you're the first people seeing this, so I wrote it just for the conference. So if anything goes wrong, I'll have it fixed in the next few days, but let's hold thumbs. Right, so we run the script. It's going to take a couple of seconds just to get loaded. Why? Because it's loading the snap-in, and we do know that takes, depending on the size of your farm and depending on how fast the server is. I mean, this is running on my local machine. I've got 5 servers running. Now, what's really horrible is that this showed so nicely on my screen, so I'll have to reduce the size, but for display purposes, what you have is the as-is topology. And yes, this is PowerShell. It's a Windows form running in PowerShell. So you've got an as-is topology and then a to-be topology. So I'm going to have to scroll, unfortunately. So what I'm going to do is I'm decided that, well, I don't really feel like having to try and type and find out what my topology looks like. So let's import it. So what we do is that just imported the topology. And it did it really fast because I used the export topology command, which exports the XML. It's a standard SharePoint command. And I've read the XML into displayed on the screen. So what you see at the top here is what the current topology looks like. As I showed you on my screen, there's my crawl components, content processing, index query, and off the screen you can't see there, but I've done them in order. It's brought back the current index location to show you where your index is currently residing. And then just to keep it even more simpler, there's a new topology in the bottom, which I've pre-selected or pre-ticked the items that already got the components deployed. So as you saw in the top, you saw there that my server 2012 R2 SP Apo 1 was my admin component. So let's say, for example, I want to change it. So because we don't have a UI, I've decided to write one, as one does. And I'm going to add, and you need to click in the box to get a check. I'm going to add a new admin component to my topology. Why not? What I'm also going to do, because I know my crawl component didn't come online, I'm decided I'm going to remove it as well. And once I'm done with this, I'm going to go along, and I'm going to be rather brave, and I'm going to click on, or there's a button here that says Modify Topology. Let me see if I can bring it up. Otherwise, I'm not going to be able to click it. Ah, come on. Oh, you can see how it's resized off the screen. That's fine. Unfortunately, this did show on my screen, so I apologize for this display. So I'm going to click Modify Topology. And when I click Modify Topology, there'll be a little display at the bottom showing you that it's going to go modify the topology, which is a lot simpler than you having to write the PowerShell to go and do that. Yeah, don't worry, it says not responding because it's busy processing. Oh, come on. So what it's busy doing at the moment is it's busy now making the changes to the topology while it's busy going, and yes, it takes time, so I left it a bit late to run it. But instead of you having to go, now to do what I just did there, you would have had to go and fetch your topology, clone it, then you would have had to go and say, oh, I don't want one admin component anymore, so you would have had to remove admin component and whatever number it was. What you would also had to do was add admin component. You would have also had to go and remove the crawl component that I didn't want, and then you would have had to go and set the topology. So I've had a few customers say, oh, but we don't want them to touch the search because now we're too scared to move the topology or to make modifications. So I'll post this on my blog. Obviously, there's no warranty of it breaking anything. I mean, it's in its version 1. But what we will see over here is that while it's busy doing this, and I'll refresh this every now and then, what we should see in a few minutes is a new admin component show up and that yellow crawler one that didn't come online go away. Because I've basically generated the PowerShell that you would have needed to modify the topology. And I only took these few days while I was here to do it, so I need to do a little bit of work and clean up and some error handling still, but it works. I tested it before I got here. Am I done? Oh, all right. All right, so I'll show you for those who want to see it afterwards. I'll show you it there. For the references that you need, this bottom one is the performance limits and where I got them from. They do change regularly, so please look on the blog. Make sure that you keep up to date with them. And then the other one is my blog where I'll post this code up. Again, no warranties on the code. I need to be very clear on that. I've kind of fit it to the size of about 1400 wide, which is why the 1024 doesn't fit on the screen. And the biggest thing you just need to remember, and I'll build in a bit of error checking for it, is that you cannot remove an active index component with the first run. In other words, when I modified the topology there, I could have gone and added an index component, modified, then gone back and removed the one I didn't want, and modified again, and then it would process successfully. If you try and do it otherwise, it will fail. And then last but not least, seeing it's the last day and my last session, thanks for coming. If there's any questions, I'm still here today. So.